From Space Launch Complex 37 at Cape Canaveral Air Force Base, this is United Launch Alliance presents live Delta IV launch coverage. On board the Delta IV today, WGS5, the fifth wideband global SATCOM system mission for the United States Air Force.
Ready to go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Delta Mission Control at T-minus 4 minutes in holding. Launch countdown is currently in a planned 45-minute hold. This hold is designed to allow launch conductor Doug LeBeau and his team time to conduct final work before countdown resumes. However, at this time, the team is not working any issues. Our 30-minute launch window this evening opens at 8:27 p.m. Eastern Daylight Time. Good evening and welcome to Cape Canaveral Air Force Station. I'm Howard Voyan and I will be your commentator for tonight's launch. Following liftoff, we'll have Steve Agid will be providing launch ascent data. Later in the broadcast, I'll be joined by Colonel David Goldstein from the Air Force Space and Missile System Center. Colonel Goldstein is the Deputy Director of the Military Satellite Communications Systems Directorate. His organization is responsible for all Air Force communication satellite acquisitions. As I mentioned, WGS5 is the fifth satellite in the wideband global SATCOM system. Built by Boeing Space and Intelligence Systems, WGS is an important element of the new high-capacity satellite communications system providing enhanced communication capabilities to the U.S. and Allied warfighters for the next decade and beyond. Each WGS satellite provides more wideband communications capacity than the entire defense satellite communications system the constellation WGS is augmenting. The launch team recently received the final weather briefing and was told that weather was in the launch commitment criteria for this evening's liftoff. So we are proceeding towards liftoff with a planned T0 of 8:27 p.m. Eastern Daylight Time. ULA is using the Delta IV Medium Plus 5.4 configuration to launch the WGS5 mission. This is the 22nd Delta IV Evolved Expendable Launch Vehicle mission since the inaugural flight in 2002 and the third flight of the Medium Plus 5.4. The Delta IV is produced in Decatur, Alabama, and is comprised of a common booster core powered by the Pratt & Whitney Rocketdyne RS-68 engine, 4 Alliant Tech Systems solid rocket motors, and a Delta cryogenic second stage powered by the Pratt & Whitney Rocketdyne RL-10B engine. The WS satellite is encapsulated in a 5-meter diameter payload fairing, which occurred on April 25th. The encapsulated payload fairing was transported to Space Launch Complex 37 and mated to the Delta IV launch vehicle on May 7th. In preparation for launch, the Mobile Service Tower, or MST, is rolled back, revealing the Delta IV launch vehicle. The 33-story MST weighs over 9 million pounds and is rolled to its launch position 300 feet north of the Delta IV launch vehicle. The Delta IV stands 217 feet tall, or about 20 stories, and weighs approximately 900,000 pounds fully fueled. It delivers nearly 1,000,000 pounds of thrust off the launch pad. For those watching the broadcast, you're looking at video taken yesterday at Space Launch Complex 37 as final launch preparations were completed. This is Delta Mission Control at T-4 and holding, and we continue to progress towards a launch at 8:27 p.m. Eastern Daylight Time. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of the ground-based cameras. While the team completes final preparations, let's take a closer look at tonight's flight.
The following profile details the important events of this mission using approximate times. The Delta IV rocket will launch a WGS, or Wideband Global Satcom satellite, for the U.S. Air Force.
5, 4, 3, 2, 1, 0, plus 1. Liftoff.
The Delta RS-68 main engine and 4 strap-on solid rocket motors ignite to lift the vehicle away from the pad. Shortly after liftoff, the Delta begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 36 seconds. At 50 seconds, the vehicle reaches maximum dynamic pressure. The strap-on solid rocket motors, or SRMs, burn out approximately 94 seconds into flight. At 1 minute 40 seconds, the first 2 SRMs are jettisoned. 2 seconds later, the remaining 2 solid rocket motors are jettisoned. At 240 seconds into the flight, the RS-68 engine initiates throttle down to 57%. Approximately 7 seconds before booster engine cutoff, the RS-68 reaches MPL, or minimum power level. The payload fairing is jettisoned at 3 minutes 27 seconds. Approaching main engine cutoff, the Delta IV is burning propellant at a rate of approximately 151 pounds per second, flying at more than 109 miles in altitude and 237 miles downrange. Main engine cutoff occurs just over 4 minutes into the flight. After main engine cutoff, the first stage is jettisoned. Second stage engine ignition takes place at 4 minutes 27 seconds into the flight. The second stage and WGS satellite are now in the first burn, the longer of the 2 second stage engine firings. Following the first second stage engine cutoff at approximately 20 minutes, the mission enters a coast phase. Just over 28 minutes into flight, the second stage engine is reignited for the second and final burn. Following the second stage engine cutoff, the second stage and payload enter a coast period in preparation for spacecraft separation. At 40 minutes into the mission, the second stage releases Wideband Global Satcom satellite for the United States Air Force.
This is Delta Mission Control at T-4 minutes and holding. Tonight's launch is dedicated in memory of ULA employee Tim Hodgins. As a quality inspector for the launch operations team, Tim was responsible for verifying flight hardware compliance with engineering and test standards, as well as the corresponding documentation, maintenance, and inspection records. Prior to his 10-year career with ULA, Tim served 14 years in Army aviation as a member of a Black Hawk helicopter flight crew, where he saw combat duty in the Gulf War and Somalia. Tim was a proud father and an inspiring teammate. His coworkers will remember his homemade barbecue, uncanny sense of humor, and the professionalism and dedication he brought to his job each day.
L minus 10 minutes. All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
This is LC with a terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
LC FMA primary wind load relief file has been loaded into RIFCA and verified. Checksum is 6 Echo 98.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 45-minute built-in hold as preparations for launch continue. Launch conductor Doug LeBeau will pull the team in a few moments for the final go to resume the Delta IV launch countdown. 31 engineers and managers will be pulled for system status and readiness to proceed with the launch. This is the final status check before launch of all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle systems readiness pull includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Final processing steps just prior to launch include completing propellant topping for both vehicle stages, securing propellant tanks, and pressurizing tanks to flight pressures. Let's listen to Doug LeBeau perform the final polling of the launch team.
L minus 7 minutes.
Status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
PNE.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
SC.
Go.
QE.
Go.
OSM.
Go.
VSE.
VSC is go.
ALC.
Go.
AC.
AC is go.
RC.
Range, weather, and clear to proceed.
LD.
MD, the launch vehicle is ready to launch.
MD.
Yeah, permission to launch.
Proceeding with the count. MEQ. Establish swing arm lock pins. Pull.
Active.
SY. Establish record on change list. Activated.
Activated.
L minus 6 minutes.
Polling is complete and the launch team has given the go for launch. The countdown will resume at T-minus 4 minutes in approximately 2 minutes. At T-minus 4 minutes, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 3 minutes 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant fill and drain valves. Also at T-minus 3 minutes 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed and the CBC liquid oxygen, liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized as well as confirm CBC, DCSS, and FTS battery voltages. At 1 minute and 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the ROFIs, or sparklers, are ignited to burn off excess hydrogen. Liftoff will occur at T0.
T-minus 4 minutes and counting.
Upper stage lock securing started. Vehicle transferring internal.
T-minus
This is
3
Delta
minutes.
Mission Control at T-minus 4 and holding. We anticipate picking up the launch count in just a few moments. The countdown clock has resumed and we are go for launch at 8:27 p.m. Eastern.
Securing started. Vehicle transfer internal complete.
CBC lock secured.
T-minus 3 minutes, 14 seconds.
Second stage lock secured at flight level. CBC pre-press started.
T-minus 3 minutes, 7 seconds.
CPC LH2 secured.
T-minus 3 minutes.
Vehicle ordnance arming.
CBC press purge is on.
Vehicle ordnance armed.
CBC lock secure at flight pressure and flight level.
T-minus 2 minutes and 30 seconds and counting. The countdown is on track as we proceed towards T0.
T-minus 2 minutes.
EPA script running.
Hydraulic press at 4,000.
CPC LH2 at flight pressure and flight level.
T-minus 1 minute, 30
T-minus 90 seconds and the launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute, 20 seconds.
Upper stage LH2 securing started.
T-minus
1 minute and counting.
Rock report range status.
Range green. Engine start box go.
T-minus 50 seconds. Minus 45.
Launch enable.
Main power off.
Minus 40.
Second stage LH2 secure at flight level.
Minus 30.
T-minus
Status
30
check.
seconds.
Go
Green
WGS.
board.
Green board.
Minus 25.
Light lock in.
Minus 22.
Sorry, I'm TVC blowdown.
Minus 15.
Rofi ignition.
T-minus 10.
T-minus 10, 9, 8, 7, 6, 5. We have liftoff. We have RS-27 main engine. We have liftoff. The United Launch Alliance Delta IV rocket carrying WGS5 for the United States Air Force. The wideband global SATCOM satellite provides significantly increased capacity to our nation's leaders, warfighters, and international partners.
Looking good.
You are hearing the voice of Steve Agid providing launch vehicle ascent data.
Passing 36 seconds, Mach 1. Vehicle now going transonic. Chamber pressure is holding good in the first stage. Solid motor chamber pressure beginning to drop off as expected. Passing 50 seconds, max Q, maximum dynamic pressure in the vehicle. Coming up on the 1 minute mark. Mark, 1 minute. Velocity passing 1,300 miles per hour. 1 minute, 10 seconds into the flight. Good chamber pressure holding on the first stage. Passing 1 minute, 15 seconds. Your supply valve is now open in the second stage. Standing by for a solid rocket motor burnout about 10 seconds from now. Burnout, standing by for SEP. We have separation of the solid rocket motors. 1 minute, 47 seconds into the flight. The Delta vehicle now only weighs 1/2 of what it did at launch 1 minute, 52 seconds ago, expelling propellant at 1,850 pounds per second. Coming up on the 2 minute mark. Mark, 2 minutes. Still looking good. Now 2 minutes, 10 seconds into the flight. Vehicle now traveling at Mach 5, 5 times the speed of sound.
C5.
Passing the area of maximum fairing skin temperature. Chamber pressure right where we want it to be on the first stage. Coming up 2 minutes, 50 seconds into the flight, still looking good. Velocity now passing 9,100 feet per second, altitude 53.6 nautical miles, downrange distance 84.8 nautical miles. Passing 3 minutes, 7 seconds. Mark 10 seconds, Mach 10. Vehicle now going 10 times the speed of sound.
Oh well.
Separation. Good fairing separation looks good. Coming up 3 minutes, 50 seconds. Events are occurring very close to their expected times. Passing the 4 minute mark. Partial thrust command. We have MECO, the main engine has cut off. Standing by for stage SEP. Stage separation. Have NEDS is deploying. Standing by for igniter spark. Igniter spark. And we have ignition. Ignition on the second stage. Second stage chamber pressure rising. Good chamber pressure, right where we want it to be.
This is Delta Mission Control at T plus 4 minutes and 51 seconds. We've just heard Steve Agad report the successful execution of events comprising the early portion of the evening's mission. The mission is now in the first of two planned RL-10 second stage engine burns, and all systems continue to operate nominally. This burn will last approximately 16 minutes. I am now joined by Colonel David Goldstein from the Air Force's Military Satellite Communication Systems Directorate. Colonel Goldstein, thanks for joining me.
Thanks, Howard. It's a pleasure to be here for the 5th WGS launch.
Colonel Goldstein, as we've just seen a spectacular liftoff of the Delta IV rocket, how does it feel seeing the 5th WGS satellite on the way to orbit?
It's a great feeling to see the launch of the 5th satellite, especially knowing how important this constellation is to our servicemen and women deployed around the world. Of course, the real work for our team is just beginning. Following separation from the Delta IV launch vehicle approximately 35 minutes from now, our team will continue orbit raising over the next 106 days. After another 49 days of rigorous testing by Boeing and the Army, because Army Strategic Command actually operates the payload, our team will reposition WGS5 from the test orbit to the operational orbit over another 24 days. So you can see from this timeline, there are still several months of hard work to do before the satellite is ready for operations.
As I mentioned earlier, the WGS system provides an important increase in capacity over the legacy system. Could you explain what that means to our troops in the field?
Sure. In order to illustrate that point, I'd like to discuss a few key capabilities of the WGS system and how it's a significant upgrade to its predecessor. First, WGS is the only military satellite communication system that can support simultaneously X and Ka band communications with cross-banding to make communicating across terminal types transparent to the users. WGS currently collects and routes real-time data through the X-band, Ka band, and switchable X-Ka band terminals being used for strategic, tactical, and comm on the move communications. Each WGS satellite has such data capacity that WGS also performs the Global Broadcast Service Mission, known as GBS. GBS is like DirecTV for our warfighters using Ka band. Finally, WGS satellites are built to communicate with airborne intelligence, surveillance, and reconnaissance, or ISR systems by Ka band. This capability provides the critical bandwidth necessary to communicate with multiple remotely piloted aircraft while simultaneously providing services to many other users.
The WGS satellite must be quite advanced to be such a game changer for the Department of Defense. Would you describe some of the unique features of the satellite?
Howard, just to put it in perspective, one WGS satellite has the equivalent capacity of the entire legacy system. These satellites provide an increased number of users' voice, data, and commanding at about 10 times the data rate previously available. Our user community consists of national leaders, ground and naval forces, embassies, and airborne ISR assets from the U.S. and our international partners. WGS enables more users to receive more information faster, giving us an advantage over our adversaries.
This is the 5th WGS satellite. How will this satellite support the current constellation?
The 5th satellite is the second of 3 in the Block 2 purchase. The final Block 2 satellite, WGS6, will be launched later this summer. Another 4 satellites, WGS7 through 10, are in production or will begin production soon. It's important to note that WGS Block 2 incorporates important technical changes from Block 1. These changes were based on feedback we received from our users. These improvements include a change to our Ka antennas as well as RF bypass capability to support users requiring larger amounts of instantaneous bandwidth. In partnership with the Australian Defence Force, we contracted for the 6th satellite. In similar fashion, we partnered with Canada, Denmark, Luxembourg, the Netherlands, and New Zealand to contract for the 9th WGS satellite. As vital U.S. allies, and in exchange for their support, our partners will receive a proportional share of WGS resources. As you might infer from the number of satellites in production and on contract, wideband communications are in very high demand. Satellite communications is a critical capability for our nation's leaders and our men and women deployed around the world. WGS will provide that capability for the next couple of decades. WGS is the only high data rate communication satellite the Department of Defense operates. It provides the primary DoD link to ground and airborne forces, as well as to U.S. embassies and other authorized users. Very soon, WGS5 will join WGS 1, 2, 3, and 4 in supporting our troops. Once operational, the WGS constellation will provide near worldwide coverage. This is achieved because WGS5 will be positioned to provide coverage to key missions within the continental United States. With WGS5, a truly global operational capability will be achieved. In fact, with the addition of WGS5, the final acquisition milestone for the program will be accomplished. Full Operational Capability, or FOC. With this additional Ka band and a tremendous increase in X band, services will be provided around the globe to ensure no disruption to the mission. This is an extremely exciting time for the United States and our international partners.
So WGS5 seems like a big step forward for the maturity of the WGS constellation.
That's correct, Howard. Declaring WGS full operational capability is a big milestone for Air Force Space Command, the Air Force, and our nation.
Well, thank you, Colonel Goldstein. That's great information. I appreciate you giving us a glimpse into the wideband system. Now, let's check back with today's mission.
Next major event is the commanding of the command receiver decoders to the off mode. It occurs shortly.
This is Delta Mission Control at T plus 11 minutes, 39 seconds into the Delta 4 WGS-5 mission. We are currently in the first of two planned RL-10 second stage engine burns, and the mission continues nominally. Our next event, second stage engine cutoff, or SECO-1, is scheduled to take place in just about 8 minutes from now. While we wait for our next mission event, let's take a look at a video highlighting the key capabilities we discussed.
Success on today's battlefield demands information dominance.
Lasers on, coming right.
I'm going to put first in.
40 seconds.
To enhance anywhere, anytime communication connections for the warfighter, the wideband global SATCOM system, WGS, is taking the high ground.
Hold on, 3 seconds.
In a constellation of geostationary satellites, WGS will provide unprecedented capacity, coverage, and connectivity. By delivering broadcast, multicast, and point-to-point connections, this system meets the flexibility and high-capacity requirements of the DoD. WGS collects and routes real-time data between all theaters of operation. Longitude, latitude, or terrain no longer limit a soldier's access to mission support.
5 Sierra is 4 kilo.
Switch to channel 1.
Sequencer start. Propulsion go. Hydraulic go. All systems continue with very good flight control.
Riding aboard an Airforce EELV and powered by the Boeing 702 spacecraft bus, each WGS satellite carries more capacity than the entire Discus constellation. WGS leverages decades of industry-leading space-proven technologies. A digital channelizer and reconfigurable antennas allow 19 separate coverage areas, connecting Ka and X-band users anywhere within the satellite's field of view. Digital signal processors and advanced phased array antennas enable shaped steerable spot beams that apply bandwidth exactly where and when the warfighter needs it. High-volume uplink and downlink networking of tactical command and control C4ISR, and battlefield management allows combatant commanders the flexibility to prioritize tasks and direct critical resources anywhere on the planet. Armed with mission-unique command and control software, wideband SATCOM operation centers will keep the constellation on track and on target. Compatible with legacy systems, WGS will augment and then replace the Navy's global broadcast services, becoming a critical node in the military's transformational communications architecture. To meet tomorrow's increasing SATCOM bandwidth requirements, WGS Block 2 satellites will carry RF bypass capabilities, supporting the ultra-wide terminals needed for improved airborne surveillance, intelligence, and reconnaissance. The mission: enhanced global connectivity, increased situational awareness, and instant delivery of critical information to the warfighter. The technology: the Boeing-built wideband global SATCOM system, WGS. The industry's best, proudly supporting our nation's best. The most important theater of operation, anywhere U.S. and coalition forces are deployed. Taking the high ground, WGS connects them all.
1-3, roger. Roger.
This is Delta Mission Control at T plus 16 minutes 47 seconds into the Delta IV WGS5 mission. We are approximately 3 minutes away from the first cutoff of the RL-10 second stage engine, and the mission is progressing as planned. Let's go back to Steve Agid for flight commentary.
Altitude now 142.7 nautical miles, velocity 24,992 feet per second, downrange distance 2,405 nautical miles. "17 minutes, 34 seconds in, about 3 minutes remaining in the burn. Chamber pressure holding very well in the second stage. Good engine control in the second stage as we're approaching the 18-minute mark. Mark, 18 minutes into the flight. Altitude now 125 nautical miles, velocity 26,143 feet per second, downrange distance 2,623 nautical miles. Coming up on 18 minutes, 34 seconds, about 2 minutes remaining in this first burn. Chamber pressure continues to hold. Good engine control. Passing 19 minutes now. Still looking good. Altitude now 110 nautical miles, velocity 27,490 feet per second, downrange distance 2,888 nautical miles. "19 minutes, 34 seconds in, about 1 minute remaining in this burn. Chamber pressure continuing to hold. Good engine control. we're passing the 20-minute mark. Mark, 20 minutes into the flight. Altitude 103 nautical miles, velocity 28,693 feet per second, downrange distance 3,110 nautical miles. Standing by for MECO, SECO, standing by. And we have SECO. The second burn will occur about 7.5 minutes from now.
This is Delta Mission Control at T plus 21 minutes and 4 seconds. Steve Agid just confirmed cutoff of the RL-10 second stage engine. The WGS5 mission is now on a coast phase off the west coast of Africa. This coast phase will last just under 8 minutes, at which time the RL-10 engine will be restarted for the second and the final burn. Let's go back to Steve Agid for mission progress.
Now 21 minutes, 55 seconds into the flight. Our preliminary orbit numbers for SECO 1 look very good. Now 22 minutes, 25 seconds into the flight. Less than 6 minutes now until the second burn. This is Delta Flight Commentary at 23 minutes, 20 seconds into the flight. Altitude now 117.66 nautical miles. Velocity 29,460 feet per second. Downrange distance 4,007 nautical miles. Our second burn of the second stage engine will occur less than 5 minutes from now. It's a fairly short burn. Duration just shortly above 3 minutes in length. Delta flight commentary at 25 minutes into the flight, about 3.5 minutes remaining until our second burn of the second stage engine. Delta flight commentary at 26 minutes into the flight. Still looking good. About 2.5 minutes remain until the start of the second burn of the second stage. Attitude control jets 10 and 12. Settling jets are on right now. Less than 2 minutes till the start of the burn. "27 minutes into the flight. Next burn to begin less than 90 seconds from now. We've changed the settling pair to ACS jets 9 and 11. This is Delta flight commentary coming up on 27 minutes, 50 seconds into the flight. Mark. Less than 1 minute now until the second burn of the second stage. This burn is fairly short in duration, just over 3 minutes. Expecting to start about 20 seconds from now. Standing by for the burn. And we have the igniter spark. And we have ignition. Ignition on the second stage. Chamber pressure rising. Good chamber pressure in the second stage. Good and stable. Good engine control.
This is Delta Mission Control at T plus 29 minutes and 4 seconds. As just reported, the RL-10 engine has been restarted. This second burn will last just over 3 minutes. Our next event, SECO 2, completes the engine burns for this mission. Here again is Steve Agid.
29 minutes, 22 seconds in. Burn continues to look well. Chamber pressure is holding. Good engine control. "29 minutes, 50 seconds in. system continues to look good. C-band beacon has been commanded off. About a minute and a half remaining in this burn. Engine control continues to hold. Altitude increasing now, 355 nautical miles, velocity 31,080 feet per second, downrange distance 5,802 nautical miles.